Good morning, ladies and gentlemen. This is my science and technology presentation. I'm Berk Özbalcı, a second-year student in computer engineering. I'll probably given this presentation a million times. It's one of my favorite topics to talk about. It's, well, the number one reason I cannot break into your online banking account. Why? Well, we'll get to why, but first, let's talk about two very difficult problems in computer science. Then we'll see how those are applied in computer science and how they keep your bank account safe. This is particularly cryptography, where your passwords, your accounts are secured. The first problem I would like to talk about is the subset sum problem. Subset sum problem is unsolved. And there is a definition of subset sum problem that goes like this. Took this from Introduction to Algorithms, classic textbook. Well, the subset sum problem, this definition is very difficult to parse. So I'll move on with an example, hopefully understandable. We have those numbers in here in a set. You can repeat any number, but this time we haven't. We'll try to combine those numbers and arrive at 0. The combination of those numbers, for instance, 10 and minus 6 yields 4. But it's not possible to reach minus 4 on those, so it's going to be difficult going that way. Instead, before the presentation, I looked at the set and I saw that the combination of those numbers will get to 0. 5, 3 will get 8, and minus 2 and minus 6 will get to minus 8, and combining them will yield 0. This is not possible for every set, though, obviously. This one, no matter how hard you try, you will never be able to find a combination that gives you 0. This problem is very difficult. If they gave you 5 numbers, that's okay. You can take your time and try them. But if they gave you a million numbers, that would be very difficult. Computer programs, you can probably write a computer program that goes through all the possible combinations of those numbers and see if they ever get back to 0, but it's not possible in this case to write a program that does this in a feasible amount of time. The technical term for such problems are called NP-complete. There's a problem which is another unsolved problem in computer science, which is the Boolean satisfiability problem. The definition of this is very harsh, so I'll skip that entirely. But here's an example. Before the example, this is also an NP-complete problem, as proved by Stephen Cook in his classic 1971 paper. The example is like this. I will use an analogy, not actual Boolean expressions. Suppose you want to go out and play with your friends, and your mother is giving you conditions. You can go out if you do your homework and do the chores, or if you don't go out tomorrow, I'll let you go out today. If you do both, you'll be able to go out this day. But for instance, if you don't do your homework, if you don't do your chores, and if you go out tomorrow, you'll not be able to go out today. We can simplify this expression by giving arbitrary symbols for those tasks. For instance, a homework is P, your chores is Q, and going out tomorrow is R. These are true-false expressions. You either went out tomorrow or you didn't. Well, it's possible to go out in this scenario. It's easy. As I told you, if you do your homework and if you do your chores, you will be able to go out. But let's say if your mother told you that you can go out if you do your homework and at the same time you don't. Well, this doesn't make sense logically. It's impossible to both do your homework and not do it at the same time. Symbolized, this will give us P and not P, which evaluates to 0 in Boolean algebra. This is impossible. So what happened there? You've been cheated. Your mother just tricked you. Let's say your mother is a human being and you're a computer, and the human being gives you an expression and tests if it's possible or impossible. Well, as proved by Stephen Cook, as I told you earlier, it's impossible to write a computer program that evaluates this in a feasible amount of time. So finally, where do we get with this? The huge application of all these unsolved problems is called, one of them is called public key cryptography, which relies on unsolved problems to be secure. Numbers, for instance, there's a very difficult problem in arithmetics called the factorization problem. It's very difficult to solve, but it can be expressed in similar problems like this. One problem translates to another. Those two problems I just showed you will evaluate to that one, and it's incredibly to solve, which keeps public key cryptography secure. But how does public key cryptography work? Suppose that Bob and Alice are trying to make a secure communication, but Eve is eavesdropping, and Bob and Alice haven't had any prior conversation. They never spoke before. They don't have any internal language. Like if I mean chair, I'm actually meaning mother. It's not the word. They haven't spoken before, so they don't have any secure means of communication. Well, public key cryptography solves exactly that. And this is very common in technology. Every website you go to, and your instant messaging applications, and finally, your online banking account relies on this. You never went to your bank and established a secure communication method on your mobile phones, on your computers. It hasn't never been done before, so you have to use the public key cryptography algorithms to keep yourself safe. And why is that safe? Unsolved math problems. So in the end, it might seem that some problems being difficult is a good thing for the good of humanity. And anything can happen. One day, maybe those problems will be solved and crypto systems will break. And if you do solve the problem, you'll find yourself at least $1 million richer, because there's $1 million prize for that problem, exactly. These are my references list. And on that note, I end my presentation. I will be happy to take your questions now.
But I do have one question, and seriously, forgive my ignorance, but what exactly is the significance of the background picture?
Oh, the background picture is not significant. It's just a picture of Chicago.
Okay. Okay, thank you very much.
No problem.